Hello guys, welcome to my YouTube channel, and today we will be continuing with the probability and statistics. We will be learning today counting techniques. Okay, so let's have it in presentation mode. There is a pointer. Yeah. So what are some counting techniques? So we will be studying about product rule, then sum rule, and some basic knowledge of combination and permutations. Okay, so what does it say? So let us understand something in the context of random experiment. Okay, so random experiment is nothing but in which the outcome cannot be predicted. Okay, so for random experiments it might be required for us to count the possible number of outcomes. Okay, so in such scenarios we'll be using these rules. Okay, so you can read this out. So we'll move ahead and start with the product rule. So what is a product rule here? Okay, so we will understand with the examples. Okay, so consider a 3-stage experiment where stage A has 4 choices. As you can see, A has 4 B choices, right? And stage B has 2 choices. So B has 2 choices, that is C. And stage C has again 3 choices ahead, right? So let us try to find out the number of ways in which we can complete the experiment. Okay, so here total ways to complete the experiment is 4, because A has 4 choices into B has 2 choices and C has 3 choices. So 4 to the 8, 3 are 24. Okay, so those are the total number of ways to complete the experiment. So that is nothing but the product rule. Okay, so yeah, and one more thing, in case of product rule, we consider for example, if you are buying 3 stocks, okay, that are different. For example, one is Birla, then one is MRF tires, then second one is Aditya Birla, and third one is ACC, suppose. Okay, so what are the chances of buying Aditya Birla and ACC cement? Okay, so in such scenarios where you use and, you can directly multiply the things. Okay, so you can consider it as and operation also. Okay, the product rule. So the next one is sum rule. Okay, so here there's a scenario. So consider the stocks in the bank, in the banking and the automotive sector. Okay, so there are stocks of banking and automotive. So in banking sector there are 3 stocks, that is bank 1, bank 2 and bank 3. And in automotive there are 4 stocks, 1, 2, 3 and 4. Okay, so if an investor likes to invest in either banking or, so as you can see in product rule I said it can be and. Okay, so it is and, not it can be, it is and it sum rule there is or in the question. Okay, so if an investor likes to invest in either banking or automotive, that means either these, either any one of these, okay, automotive stocks, then how many total possible ways can we invest? So total possible possibilities to invest in either banking or automotive sector is 3, that is 1, 2, 3, and the 4, 3 plus 4, that is 7. Okay, so these are the total number of ways in which you can invest in either of the stocks. Okay, so that is nothing but the sum rule. So the next is combinations. So combination is nothing but a selection, as you all know. Okay, so we will understand it by an example. Okay, now here consider the stocks again, that is stocks of automotive industry. So auto 1, auto 2, auto 3 and auto 4. Okay, and here's the question. So if an investor wants to invest in 2 automotive stocks, so in how many possible ways can he invest? So there are 4 stocks, but he want to invest it in 2. Okay, so total possible ways are 4C2, that is 4 factorial, and then 2 factorial, and 4 minus 2, 2 factorial. Okay, so 4 into 3 and 2 get cancels, divided by 2 again, so 4 is at 12 by 2, that is 6. Okay, so the combination formula is NCR n factorial upon n minus r factorial and r factorial. Okay, so here NCR is number of combinations, n is total number of objects in the set. Okay, so here 4 is total number of stocks, and r is the number of choosing objects. Okay, so out of 4 we are choosing 2 here, that is r. Okay, so in such scenarios we can use combination technique. That means if you want to choose something or select something. Okay, so the next is permutation. So permutation deals with order or the sequence. Okay, and here's the formula. So here the r factorial is not there. So in case of combination there is extra r factorial beside this bracket or outside this bracket. Okay, that means r factorial is multiplied to n minus r factorial in case of combinations, but in case of permutations it is just n factorial upon n minus r factorial, where n is total number of objects and r is number of objects selected. Okay, so let's consider a scenario here again. So we are considering banking sector here. Okay, so bank 1, bank 2 and bank 3. Okay, so here's the question. So if an investor wants to invest in 2 banking stocks out of available 3 banking stocks, how many ways can he invest if order one at a time? Okay, so we want to order it one at a time. Okay, so that means total possible ways to invest is 3p2. That means total 3 stocks are there and we want to order, that means he wants to invest in 2, so 3p2. Okay, so 3 factorial, 3 minus 2 factorial, so that gives 3 to the 6. Okay, now don't get confused because here the answer is 6, because here the stocks are 4, but in case of here there are 3. Okay, so don't get confused like why the answer is same both in case of permutation and combination. Here there are only 3 stocks, but if you want to arrange it by selecting 2, then there are 6 ways. Okay, and here also there are 6 ways. Okay, because we are selecting out of 4, right? It comes 6 only, right? 3 minus 2 is 1, 1 factor is 1, 3 into 2, yeah, 6. So next is axioms of probability. Okay, so if you consider a finite sample space, finite means it's a whole number, not a continuous or a distinct set of values, you can say. So in case of finite sample space, let's consider an event A. Okay, so the probability of event A, which is real number assigned to the event A, so must follow the following axioms. Okay, so what will be the rules or set of rules, you can say, which will be followed by this probability of A. So probability of A should always be greater than or equal to 0. Okay, and probability of sample space is always equal to 1. Okay, and if event A and event B are mutually exclusive, then probability of A union B is equal to probability of A plus probability of B. Okay, so here A intersection B is null. Okay, that means no common elements are there. Okay, so these are some axioms you need to remember. Then there are some elementary properties. So probability of A is 1 minus probability of A. Okay, and probability of phi is equal to 0, that means it's null. And probability of A is less than probability of B if A belongs to C. Okay, that means you can say A is a subset of B. So probability of A is always less than or equal to 1, and probability of A union B is equal to probability of A plus B minus probability of A intersection B. Okay, so these are some of the properties that you need to remember when you solve any questions related to probability. Okay, so what is this? Okay, so here's one example to understand the probability. Yeah, okay, that is computing probability. So let's try to understand computing probability by taking an example of a box having 3 red balls, 2 blue balls and 1 green ball. Okay, so let's take one ball randomly. So what would be the probability that the selected ball will be a blue ball? Okay, so first you need to calculate how many total balls are there, that is 3 plus 2 plus 1 is 6. Okay, so total balls are 6, and which color ball you want to select, that is blue. Okay, so how many blue balls are there? 2. Okay, so total blue balls are 2. Okay, so it will be 2 by 6, that is 1 by 3. Okay, so the probability of drawing a blue ball is 2 by 6, that is 1 by 3. Okay, so this is a computing probability, or the simple question to understand the probability. Okay. So the next is conditional probability. So what is conditional probability? So it is used to determine the likelihood of an event when a partial information about the event is known. Okay, for example, you have two situations where one complete value and other the partial information is given. Okay, so based on that one complete value, you will try to infer the complete result. Okay, so here's the example, so you will understand the conditional probability, and you need to remember this formula of conditional probability: P A by B, that means where event B is given, okay, and a partial information of event E is there. Okay, so probability of A intersection B by probability of B. Okay, that is the formula of conditional probability. So here's the scenario. So in an experiment of rolling a die, what is a likelihood that the outcome is 2 given that the outcome is even? Okay, so here they have given that the outcome is even, and what is the likelihood of the outcome is 2. That means we need to calculate the outcome of 2. That means what is the probability of getting 2 whenever there is an even outcome? Okay, that we need to calculate. So consider a fair roll of a die. So all the outcomes of experiment have an equal probability of occurrence, that is 1 by 6. That means you have probability of so there are total 6 outcomes, right? That is 1, 2, 3, 4, 5 and 6, right? So probability of 2 is 1 out of 6, probability of 3 is 1 out of 6. So that means each outcome has the probability of 1 by 6, right, out of total, right? So that is the probability of occurrence of single element. So what we need to calculate here is outcome being 2, that is considered as event A, and given that the outcome is even, that is considered as event B. Okay, so what they have given is, it is given that the outcome is event B, right? So possible values are 2, 4, 6. That means if the outcome is even, then the possible values out of 1, 2, 3, 4, 5, 6 is 2, 4, 6, which are even. Okay, so there are total number of elements of B are 3, right? And even A can take only one value because we want to calculate for 2. Okay, so that is 1. So value amongst 2, 4, 6. So therefore the total number of elements for event A is 1, right? So the probability will be 1 by 3. Okay, you got it, right? So basically 2, 4, 6, as you can see here, number of elements of B is 3, and number of elements of A intersection B, that is 1. Okay, that is how you calculate. So in this way you can calculate the conditional probability. Okay, so hope you learned something from this video. So if you learned something, do hit that subscribe button, and till then, take care. Bye bye.